Hey everybody, Mr. Bells here. So this video is going to be on section 5-1 for geometry, section A. It's about triangles and different types of triangles and a few different things with those. Getting into working towards our way of being able to prove that triangles are congruent. So this is again section 5-1. Here we go. So we're going to start off using our student journal. Hopefully that will be helpful for you. And in our student journal, we're going to talk about things called interior angles, exterior angles, and what a corollary is. Okay, so here we go. So interior angles, so on any triangle, interior angles are the ones that are on the inside of that triangle. That makes pretty good sense, right? So then what the heck's an exterior angle? So if I extend this, one of the lines out in this direction, and this angle right here is considered an exterior angle for, we'll call this angle A right here. Just like if I extended this out right here, this would be an exterior angle B for this angle. And if I put a little C here and extended that out, that angle right there would also be an exterior angle. Now you're wondering, well, why is that side one? Well, if you extend this out this way and you put the dot right there, you could say that that angle is also exterior to angle C. And then you realize, oh, look at that. Those two exterior angles are both congruent because of the vertical angles theorem. Okay, so what's a corollary? So a corollary is like a theorem that we could prove, but it's so close to another theorem that we've already proven, and we don't call it a theorem. We just say, hey, it's so close to it, we're just going to call this a corollary. It makes sense. So one of the things that you guys got to know, and I hope this is totally good, is this. It's kind of a proof to why angle A and angle B and angle C, that the measures of an angle A plus the measure of an angle B plus the measure of an angle C of any triangle has to add up to 180 degrees. Okay, so why is that true? Well, it's true because if you know that this, here's one side of the triangle, right? If I extended this and I made this a line and I put a point right here, you know that there's one and only one line that's parallel to that line that goes through that point, correct? Good deal. And if this line is parallel, and we know that we can create that line, or even do a construction, because we've done that earlier in class, we know that since those two lines are parallel, that if this is angle A right down here, then this also has to be angle A right up there, and those two things are congruent because they're alternate interior angles between these parallel lines. And if that's true, then over here on this side, this angle C must be the same as that angle C, and those two angles are congruent because of alternate interior angles. And now you can see that angle A plus angle B plus angle C are three angles that form a straight line, which means that's a straight angle, which means A, B, and C have to add up to 180 degrees. And A, B, and C are the same as the three angles in the triangle. So there's your quick little proof on that. So the corollary that they're going to be talking about is this one right here. Basically it says this, that on any triangle like this exterior angle right here, we'll call it M, you know that M and dot have to add up to 180 degrees. So exterior angle M and this dot have to add up to 180 degrees. Well, you know that dot and X and Y, right? So if dot and X, dot plus X plus Y equals 180, and dot and M equals 180, then that M must equal X plus Y. And that's called the exterior, corollary to the triangle sum theorem. Basically says this, that any exterior angle is equal to the sum of the two non-adjacent angles of a triangle. So that, I'll give you a quick little number scheme here. That if this is 25 degrees and this is 70 degrees, and this is 85 degrees, right? That adds up to 180. That if this is 25, then these two things form a linear pair, and that means that this has to be 155 degrees. And you can see that 155 degrees is the sum of those two angles. Okay? So we're going to talk about now triangles and how to name them. So we can classify triangles by sides. Scalene has no sides that are same length. Isosceles has two sides, and this is kind of weird. It says at least two sides congruent. And then equilateral has all three sides. So technically, an equilateral triangle is also an isosceles because it has at least two. It's just more specific in the fact that it has three. Okay, but if it has at least two, it's also considered isosceles. Now, if we classify triangles by angles, there are basically four types. Acute, which means all three angles are less than 90 degrees. Right, which means there is one right angle. Obtuse, which means you have one angle that is greater than 90 degrees. And again, you can't have two angles that are greater than 90 degrees. That's impossible because all three of them have to add up to 180. And you can't have a negative angle. And equiangular, and all three of those have to be 60 if they're all the same, because they have to add up to 180, right? Because 180 divided by 3 is 60. And you can see, I'm hoping you can see this, that anytime that you have an equilateral, you also have an equiangular, and every time you have an equiangular, you also have an equilateral. Okay, that's another statement or corollary that they have in the book. Okay, so how do we work with some of these things? How do we do it? So you can see right here that there are three separate theorems, and I just kind of talked about one of them. Triangle sum theorem says that any three angles of a triangle add up to 180. The exterior angle theorem that says that any exterior angle is equal to the sum of the two non-adjacent angles of a triangle. And this one down here that says on any right triangle, the other two angles right here, A and B, must be complementary, must add up to 90 degrees. And I'm hoping that that makes sense. But that's a pretty obvious situation. Because once I take 90 degrees away, the remaining two things have to add up to 90. Okay? So right here, we're going to practice some of these things. So this stuff says, hey, go ahead and measure some things. And you can measure them with your protractor. You can measure them with, measure angles with the protractor. You can measure side lengths with it. I think this one's pretty obvious, that this gets this, gets this. So that is scalene, because none of those three sides are the same length. Good deal. However, this angle is greater than 90 degrees, so this would be considered an obtuse scalene triangle. So it gets both names, obtuse for the angle, scalene for the sides. This one over here is isosceles, and there's something that we'll find out later that says if these two sides are congruent, then the two angles opposite those sides are congruent. And this one right here, I didn't measure it, but I think you could measure it. I'm pretty sure that that's going to be 90 degrees. So this is a right scalene, and this one would be an acute isosceles. So those are kind of the names that you could give them, and hopefully you'd be able to do that on a quiz or something like that too. Okay, so let's go down here and we'll do some math stuff. So this says, hey, find the measure of angle 1. Well, I'm hoping this makes sense, that angle 1 should equal the sum of these two other angles. So it should equal 106 degrees. I'm going to show it to you two different ways. So first, 53, 53, and x are the three angles of this triangle. So if that's 106 degrees right there, then I know that this angle right here is 74 degrees. And if this is 74 degrees, this has to be 106 also, because they are supplementary, because they form a linear pair or a straight line right there. Okay, over here on this one, how do I summarize this thing, or how do I find that? Well, I know that this must be true, that 40 plus 5x plus 15 is supposed to equal 8x minus 5. That an exterior angle, 8x minus 5, is equal to the sum of the non-two adjacent angles. So this is the adjacent angle, so that has to equal the sum of the other two. And now that's just algebra, and you can go ahead and solve that algebra equation. Okay? Move this up a little bit so you guys can see this better. Go ahead and give that a shot right now. You can pause the video, try it. Remember that when you're done, if you find x, that's great, yay, x, but we're trying to find the angle, which means you have to take whatever your x is, multiply it by 8, and subtract 5 to find that exterior angle. Okay? So, hey, look at that. That takes us to 5-2. So all of the stuff that we just talked about is what you need to know for 5-1, and we're going to call that good. Actually, let's do this one. It says in a right triangle, the measure of one acute angle is twice the sum of the measure of the other acute angle and 30 degrees. So what I'm going to do is this. Say there's my right angle. And it says one acute angle is twice the sum of another measure of angle and 30 degrees. So let's say I don't know this one. Well, this one has to be twice that angle plus 30 degrees. Ooh. Find the measure of each acute angle in the right triangle. Well, I know then 2x plus 30 plus x, those two angles, must equal 90 degrees. That's from the corollary to the triangle sum theorem. And I can go ahead and do that algebra. Remember again, you're going to find x, and then you got to plug it into each of these two expressions to find out what that actual angle is. This is Mr. Bells. I will talk to you guys later. Hopefully this was awesome help for you in this section.